This video is going to demonstrate how to do some deblurring using the CopyCat tools in Nuke 13. This is the script we're going to be making in this video. It's not too complicated, as you can see. In the example clip, this woman starts off in focus and then takes a step forward and drifts out of the camera's focal plane, and by the end of it, her face is quite soft, as you can see in frames like this. This video is going to be showing how to take some of the high frequency details from her face when it's sharp, and then put them on top of a softer frame and also match the lighting, and then train the CopyCat algorithm on the difference between the two. This inference node here is the eventual output that we'll be getting by the end of the video. As you can see, as I'm toggling it on and off, it brings back a lot of sharpness in the eyes and around the mouth, some stuff on the specular highlights of the nose, and also the detail in the hair. So let's get started. I'm just going to copy the footage over on the right hand side here. The first thing I'm going to do is just grab this frame range node and copy and paste it under the footage. This is just setting the frame range to a certain part of the clip, so we're using between frames 510 and 566. Then what we want to do is select the two frames we want to use to train CopyCat on. In this case, we're going to pick a frame where her face is sharp at the beginning of the clip, and then a frame like this where her face is soft at the end. I'm going to go for this frame here, which is 523, so I'm going to add a frame hold on this frame. And then I'm going to use 540 once her face becomes a bit soft as the second frame. Now we have these two frames set up, what we want to do is take the details from the sharp frame and move them over onto the softer frame. So the first step of this process is going to be warping the sharper frame into the same position as the soft one. To do that, we can use a node in Nuke called the vector generator, and I'm going to plug it in under the soft frame. Then what we want to do is create a switch that goes between the soft frame and the sharp frame. So add a switch node, plug this in underneath the soft frame as well, and then take the one input and plug this into the sharp frame. Then what we want to do is add a defocus node and roughly match the sharpness of this soft frame on the sharper one. So I'm going to add a defocus node and plug this in between the switch and the sharp frame. And if I switch between the two like this, I'm just going to increase the defocus amount until the eyes feel like they're a similar amount of sharpness. Something like that looks pretty good to me. Then in the switch node, I'm going to go to the very first frame of the comp, and I'm just going to keyframe it to go from 0 to 1. So 0 on the first frame, and on frame 2, I'm going to add a new keyframe and set it to 1. Now if I look at the vector generator, and I look at the channels, we have the RGBA channel, which is the default one, and then we also have backward and forward. These are the motion channels that are being generated by the vector generator, and we can use these to warp the sharp image on top of the softer one. To do this, we first want to copy these motion channels into the stream of the sharp image. So I'm going to add a shuffle node, plug it in under here, and then I'm going to take the A input and plug it into the vector generator. Then on the second input in the shuffle node, change in from B to A, and then set both of these to motion. Then you can click and drag the 6 dots down here and drag it across, and it will connect all of the channels together. Now you can see we also have those 3 channels in this stream. And then I'm going to add an eye distort node to utilize these channels and deform the image. Set the UV channels to motion, and if I go back to the first frame where the image is being warped, if I turn this on and off, you can see the sharp frame is now being warped into a different position. And if I compare this with the soft frame, we now have the sharp image essentially overlaid on top. Now that we've warped the sharp frame into the correct place, we can cut out just the bits we want to train the CopyCat model on. So I'm going to add a roto node, turn on replace to overwrite the alpha channel. I'm just going to cut out a bit of the fringe, her face, and the hair on the side of her face. Then add a pre-molt node to cut this out. I'm just going to blur the alpha a tiny bit as well. Next, you want to add a merge node and overlay this on top of the soft frame. So I'm going to plug the B input into the frame hold up here, and then the A input into the pre-molt, so we have our cutout image on top. And that should look something like this. We're pretty close now to having a usable result, but you can see that the lighting on her face is changing slightly. She stepped forward a bit in the room over the course of the shot, and I imagine there's probably a light above her head that's casting some different shadows on her face now she's in a different place. So what we want to do is extract the lighting from this original source that's soft and put it on top of the sharper version. To do this, I'm going to blur it by about 30 pixels to remove any of the high frequency detail. Then I'm going to duplicate this node by pressing Alt-K to make a clone of it and plug this into the original source. Then I'm going to merge these two together and set the operation to from. I just want to swap these around, so I'm going to select the merge node and press Shift X, which changes the inputs over. So now what this is doing is essentially taking this image away from this image. And the output, if I turn this up slightly, as you can see, is the lighting detail that's just left over between the two. So what this is really giving us is the lighting that's lacking in this frame, but present in this frame. So now what we can do is put this back on top. So add a merge node, plug the B input into the first image and the A input into the second, and set this operation to plus, which is going to put this on top. Now if I toggle that on and off, you can see that that's adding the lighting back. And if I compare this comp to the blurred original image, you can see that they're now very similar. And then finally what we want to do is put this high frequency detail back on top, so we have the lighting the same and also all of the sharp image that we restored earlier. To do this, we're going to add a third merge node, plug the B input into the original sharp image, the A input into the blurred version of the sharp image, set this operation to from as well. And as you can see, this is just going to give us the high frequency detail that's lacking in the blurred image. We can then take this and plus it back on top down here. So add a fourth merge, plug the A input into the high frequency detail, and if I look at this and set it to plus, turn my viewport down a little bit, you can see this is now restoring all of the sharpness in the detail in the face. So now this is our final result that we want to train CopyCat to try and achieve on every frame. Again, this is the final result that we just made, and this is where it started. So you can see that we've moved all of the high frequency detail into this version of the comp. Now all we have to do is train CopyCat to recognize the difference between these two. So to do that, just like other CopyCat techniques, we have to give it a ground truth and an input image, which will be our original source. You can also create a cropped version which we can feed it, which will hopefully increase the data set slightly. So add a crop node, and then we can just set this to an area of the face so it's a bit more cropped in. If I tick reformat, this will scale up to the full frame. Then I'm going to add an append clip node, plug the first input into the original image, which is the full frame version, and then the second input into the crop. As you can see here, the append clip node is currently looking at the entire frame range of the sequence. So what we can do is come up here and add a frame range node and just set both of these to 1, which will then make the append clip node just recognize it as a single frame. So now we essentially have a 2-frame image sequence, which is the full frame version and then the cropped version, and we're going to feed both of these to CopyCat using the append clip. Then just to be neat, add a remove node, set the operation to keep, and just set the channels to RGB so we don't have any extra data that we don't need. Then we want to do the same thing with the original source material. So I'm going to take these 3 nodes, copy and paste them over here, and plug them in up here to the frame hold of the soft image. Now if I toggle between the two, you can see we have the soft one and the sharp one here, and we also have the cropped version of each. Then finally I can select both of the remove nodes and add the CopyCat node. Make sure that the input is the original source material and the ground truth is your comp. Then inside of the CopyCat node, open the Advanced tab, and we're going to change initial weights from none to deblur, which is the deblur training algorithm. After that, what you want to do is set your data directory. It's a good idea to put this in its own folder because this makes loads of files. And then you're ready to go, so press start training and wait for it to begin. If you want a bit more information about what it's doing as it goes, the terminal will give you a real-time readout of what's happening. So you can see here when it was compiling the CUDA kernels, and then once it started, it's now giving you a real-time readout of all the training that it's doing. As you can see, as it's training, we have this box down here which shows the progress. The left-hand side is the input, which is the unchanged source file, which is our footage. The ground truth is the comp that we created, and the output is the eventual result that CopyCat will create. Okay, the training is finished. Let's have a look and see how it's done. So to preview the result in the CopyCat node, what you want to do is press the Create Inference button, which is this one here on the right. And then that's going to create the inference node, which is here. The inference node contains a file path to the CopyCat training files. And when you plug it in, you'll see the result of the training. So what I'm going to do is take it and plug it into the frame range node at the beginning so we can preview it on the shot. It was between 510 and 566, so let's just go to the input. And let's choose a frame where it was visibly soft before. So I guess 540 would be a good one because that's the soft frame that we picked for the frame hold. And if I look at the inference node, you can see that it's making the image substantially sharper. It's bringing back a lot of clarity in all of the specular highlights, stuff like you can see on the teeth there, the highlights become a lot more defined, and you can also see the reflections in the eyes become a lot sharper. It's bringing back a lot of the detail in her hair, her nostrils become a lot sharper, as well as some of the highlights on her nose. So it's doing a really good job. Let's have a look at it on some other frames that weren't the ones we trained it on, because that's ideally what CopyCat does, is it applies it across the entire sequence. So there again, it's soft. And then when we turn it on, it's restoring a lot of sharpness. From here, what you can do is just use this straight over the footage, or if there's just bits that you would like to keep and areas that aren't working quite so well, like the hair for example, you could key mix just the part that you want to bring back just the relevant sections. If you get to this point and you find that the training hasn't been particularly effective, what you can do is increase the epochs number in the CopyCat node. This allows for more training iterations and it will train the algorithm for longer, and then hopefully your result will be more accurate. So there we go, that's a demonstration of how deblurring works with CopyCat in Nuke 13.